Okay, guys, we were discussing about the data modeling aspect of this. Under that, we discuss what we call entity relationship model. We look at how we can create entities and relationship based on the description given to you. And there are like some of the things that the what the phases also we have discussed, right? And the example given to you is called company database, and I will take this throughout this session. We have, after finishing this part today, we are going to start the SQL theory part. There also I'm going to use the same company statement. So which means starting from the description, we discuss how to come up with the what we call conceptual diagram like this, which is very helpful in the beginning. This is not the final table structure, but instead very high level overview of your database design. Now, the second part is based on this, we need to what we call, we need to create relations. So when we want to create relations, we are going to convert all these all the entities and all the relationships, we convert into something like this. This is another representation where we convert each and every entities and relations into what we call relational database, where we have all the relations, or you can say tables. This is called the logical model. And then we create our last model, that physical, using SQL. Today we will discuss how we can, for example, convert this employee relation into a SQL statement. And next session, we are going to create it. So that's the plan. Right, now things we're discussing so far, we discuss, right, things like, let me just take into this. So the last time we discussed how we can start from this, that means the ER, into something like this. So the few things that we have discussed in the beginning, there are few things that you need to know. For example, you start with, mapping regular entities. What we discuss is we put down all the regular entities as relations. So we create relations and we include all the simple attributes. So which means what we do, right? We will get all our regular entities. So what are the regular entities? We have employee here, we have department, we have project. And this is not a regular entity. We discussed why we don't have key attribute here. We have something called partial key here. So these three we convert as relations. So here is how we convert. We will get employee and we'll get project and we'll get department. And we'll add all the simple attributes. When I say simple attributes, so for example, if you take name, this is compound, and these are the components, which are the simple attribute: first name, middle initial, last name. So which means we include first name, middle initial, last name. And then we have social security number here, we have social security number, and then we have birth date. I will put like this so that, a birth date here. And then we have also address, and then we have, okay, sex and the salary, which is also, sorry about this, are simple attributes. So these are all our simple attributes. So that for the employee. Similar to that, we will include all the simple attribute for other regular entities, name, number, and locations. So we have project name, number, and location. These are all simple attributes. And here we have name and a number. Location is not a simple attribute. So therefore, we include both name and number for a department. So we have department name and number, right? So this is our first step by following the first, right? And the second one is, once you do this, you identify one of the key attributes as a primary key. What do you mean by primary key? If you go here, you can see employee, we have one key attribute. Key attribute means it's unique for each and every instance. Each and every employee, you have a social security number, which is similar to our national identity card. Similar to that, department, we have two key attributes. That means the department name and department number, both are key attributes. Project, we have name and a number, both are key attributes. Now, what we say here is, one of these we have taken as primary key. If you have like several key attributes, we take one as a primary key and we underline it. So you can see underline. Right. So when we have department name, department number, both are key attributes, but we select one of them as a primary key and you see underline. Similar to that, project also, project name and the project number, both are key attributes, but we select project number as a key attribute. So that's our first step. Right. Then mapping weak entity types. So if you look at weak entity type, we have only one weak entity type, that is dependent, right? So we have dependent here, it's the weak entity type. And for weak entity type, we create a relation. So we have dependent and we include all our simple attributes. So these are all simple attributes. You can see all are simple attributes. Now the primary key, you cannot have only dependent name because it's a partial key. Therefore, what you do is you combine both this partial key together with the primary key, which is the identifying relationship. So you get the social security number. By combining both, you create the primary key. So that's what we discuss about the weak entities. Then third one, we discuss how to map one-to-one relationships. So if you look at one-to-one relationship, if you go back to our diagram, we have managers relationship. It's one-to-one. How do you map one-to-one? There are three options. If both the sides are total participating, then we can merge these two relations. And in case if you are using foreign key approach, we discuss what a foreign key is. One way to talk about this, take one of the primary keys and put the other side of this, right? Which makes the connection. Now to do that, we discuss best put into the total participation side, which means all the departments, you have a manager. So what you do is you take this social security number, you put it as the manager social security number. So you can see in this particular case, we include manager social security number for this. Not only that, since we have an attribute which connects us to this, that also we have included, right? So that's how we take these two attributes. Now that's about one-to-one. The third option is you can have a cross table. Cross table means creating a separate relation to make this connection, which I'm going to discuss with many relations. Right. Now, having said that one-to-one, the next thing we discuss is one-to-many relationships. So when you look at one-to-many relations. There are a couple of one-to-many relations, right? So we have a works for relation, this many-to-one relation. But remember, in this particular case, we go for foreign key approach and we put the primary key is in the other side of this. So that means here the primary key is the department number, right? Department number is the primary key that we will put in the employee side. We call department. This is the foreign key approach where we make the combination. So whenever you want to find something, for example, a particular employee who works for the department, you use this foreign key. That foreign key will connect to this primary key. So that's how the connections are made. Right. Next one. Another one-to-many. So this also one-to-many relation. Controls. So we know that you take the primary key, put in the project side, right? So what we do, right? So we get the department number, put it this side, right? So this is again foreign key approach, which connects the primary key of the department. So from this, we can get to know the controlling department. Another one-to-many. Right? So here also we have one-to-many, but this is called recursive relationship. What do you mean by recursive relationship? You know that this is a relationship, but this connects to the same entity type, which indicates that some of the employees are supervised by some of the other employees. So to make this again, we can make the foreign key approach, which means we have to get the same social security number, put it as a supervisor social security number in the same table. So if you look at this is how we get supervisor social security number, which refers the same social security number in the table. So that's how we can talk about one-to-many relation. Okay, last one, the next one, many-to-many relationship. When you talk many-to-many relationship, we are going to create a separate relationship. So that's how we manage many-to-many relations. So how do you do that? Let's look at a many-to-many relationship. So we can see that this is many-to-many relationship works on. That means many employees works for many projects, isn't it? So what we do, whenever you have a situation, you create a separate relation. That means we create a relation called works on, right? So we have a relation called works on. And then what we do, we take the primary keys of the two participating entities. One is employee social security number. The other one is the project name. So we'll get social security number and the project name together. When you combine together, we make the primary key for this. Not only that, you have a number of hours you work on a particular project that is also connected to this relation. Therefore, you got this here. Right. The last one, multi-valued attribute. When you have multi-valued attribute, this is multi-valued attribute. Again, you create a separate relation. So that's what here, department location. And then what do you do? So you will get department ID, department number. And then we have department location. So we can have both department number and department location. By combining the two, you will get the primary key for the department locations. Okay, so those are the things that we need to discuss when we make the mapping, right? So I hope you got an idea how we map the ER diagram into logical diagram. So if you start from the very beginning, the steps for this is you map the regular entity types. Step 2, you map the weak entity types. Step 3, you map the binary one-to-one relationship type. Then we have fourth step mapping of binary one-to-many relationship type, mapping of binary many-to-many relationship types, and then mapping multi-valued attributes. Again, we create this. So if you compare, you can see in ER modeling, we use to get very high level of the system. And then within this relational model, we use different names. For example, entity type, we say entity relation. For in key, you will see something like that, right? Okay, any questions after this? So I hope, given a description, you should be able to come with ER and then the model. Right. Shall we move to the today's session then? So today's session, I would like to introduce a structured query language which we use to manipulate the databases. So in this one, we will have a detailed discussion what query language is, SQL is, what are the applications, what are the opportunities you have if you master SQL. Right. Before we start, formally understanding the practical implementations of SQL. So in this module, we are going to focus on Oracle databases. One thing you need to remember is Oracle is a relational database management, and it has the largest market share among the relational database management system, especially in industry point of view. So although we discuss Oracle, there are many other notable ones. For example, IBM DB2, Microsoft SQL Server, SQL PostgreSQL. Right. Now, other things why we have selected Oracle, just give you some ideas why we may have selected this one. Again, the database that we are going to discuss can be used in any of the operating system, common ones, Windows, Unix, Linux, and so on. And then we can use network stack for smooth cross-platform communication. Asset compliance, ensure data integrity reliability. We will discuss what asset is. Then commitment to open source technology, especially this is also operated in Linux environment system. And there are many features why people may have chosen Oracle database. Right. Now, the first task is usually when you are going to learn anything, you need to select which database edition you are going to choose. So usually you can see Oracle's commercial edition of database is called Enterprise Edition, or in short it says E. Right, so that means there's no limit for the CPUs, no memory database size limits, and so on. But if you go for standard edition, it will limited to only 4 CPUs, including many features but fewer than E. Last one, expression edition, free, limited to 2 CPUs, 2 RAMs, 12 user data, and so on. So these are the 3, but we have decided the expression edition. Small question from everyone. How many of you have already installed this? Can you please raise your hands if you have installed in your machine? If you are sure that you have Oracle in it, can you please raise your hands? Right, thank you. I think many of you have already installed. Now, apart from these two, so we need basically more practicals. We need this. Definitely, we need the expression edition. Uh, Assuming that you have installed, let me show you like what we can observe. So let me share my screen. And if you look at, if you go to OLAPS, and if you install Oracle, if you go to Oracle, and this is where I have installed my Oracle database. You should see some links like this. Yes. So if you go to OLAPS Oracle, let me close this. I have already opened. So I'm going to go to my Oracle. And then can you click on this one, SQL Plus? Yes. How many of you were able to get up to this point? Right. Um, One thing is, I will ask you to download Oracle SQL Developer as well, but initially I would like to get familiar with the command line interface. This is called command line interface, where we can actually type and see, right? Now, for example, just see whether this is working. We will say sys as this DBA. So that means we are going to log in as a sys user with the password that you have installed. In my case, I have no password, which will connect to the Oracle database 21C Express Edition release 21.0.0.0. Yeah. If you finish up to this point, can you keep on raising? I will stop. for the recording for the time being. Okay, in this section, I'm going to talk about the SQL, which is the language we use to communicate with the databases. And SQL is a common language we use. So that means most of the command that we learn here can be applied in other database systems without any problem. But there are some slight differences in different databases. For example, I will stress out when things are different in Oracle. For example, when you talk about the data types, I will discuss variable character varchar is slightly different in Oracle. Creating a database is slightly different from Oracle compared to others. Likewise, I will talk about when there are some changes. Otherwise, most of the things that we discuss is as a language will be common to any of the database systems. Keep that in mind. So the main aim for this session is give you basics of SQL to interact with the databases. And I will also particularly focus on Oracle database. And then I will also discuss various ways that you can actually query the data. Query means like getting out of the data. So we will discuss how we can create tables, how to modify them, how to delete them, and so on. Right. Let's get started. So when we talk about the SQL, it's actually known as a comprehensive database language, which we can use to describe as a data definition language, which we use to create databases, to create tables, and so on. And then it has a data manipulation language, which we can use to, manipulate the data. So under this one, we can also see other extra information as well. So for example, we can talk about views. I think we discussed the idea of views. That means different users can see different part of the database, which is in the external. For example, managers want to see, for example, summarized data, whereas general users want to see, raw data about particularly suit for them. Then we can talk about security authorization, meaning like who are permitted to enter the data, change the data, and so on. Transaction control, which means sometimes if something goes wrong in the middle of the change of a database, what should happen? For example, let's say you are transfer fund from one account to the other. What will happen if the power goes in the middle? Right? How do you handle that? So those things we have to talk about under the transaction control. Or else, for example, multiple users can access. So if something goes wrong, how do you handle it? So those things we discuss under transaction control. Finally, you can talk about embedding SQL. These SQL statement can be used together with other programming languages, like with Java or Python, especially when you want to develop database applications. So having got the basic idea of SQL, let me talk about the terminologies I'm going to discuss. So remember, I use the term relation and sometimes the tuple and attribute in relational model. So these are the terms we use usually. When it comes to SQL, all the relations we talk about tables like employee table, project table, department table, likewise. Then we talk about the individual data points as rows. For example, employee table, you might have 7 or 8 records. We call rows. Okay, we will have 7 or 8 rows. Then remember, we discussed attributes. Attributes will become columns in SQL. We talk about different columns. Okay, so with that said, let me start from the beginning. Now, usually, when you want to create something in a database environment, you start with creating a database. So the command for this is usually in SQL called create schema. But in Oracle, we don't have a create schema command. Usually you create a user. So I can show you this, but I'm not going to confuse you. So for example, let's say I want to create a company database, right? Remember our example is about the company. So I start creating a user first. So I will say create user company and I'll provide a password. So when I do that, what will happen? You create a user called company, but creating a company, right? It will create a database as well. Then you connect to the company database and then you can create the tables inside. So that's the very starting point. So you start with creating a database. In Oracle, creating a database means you create with the user. So that's how we start. Right. Okay. Then you create tables. Remember our database earlier we discussed, we had employee table, we had project table, we had department table, we had dependent table. So how do we create a table, right? So you have to create table. So here is the command we will normally use. So table, you provide a name and then you list all the attributes and any constraints. I will explain what the constraints are. And then when you talk about attribute, we talk about its data type. Okay, let me give a more detailed explanation. Now, when I see an attribute, for example, employee table, we had first name and last name. So we have to say, okay, what those are. Obviously, you know that you are going to include text, right? So we need to find data which reflects text, isn't it? Another attribute, let's say, we want to get, right? We want to get, for example, date of birth. So it's the data type is a date. So we want to keep it as a date. So likewise, we have to specify what data types are. So with that said, usually it will look like something like this. So for example, if you look at our department relation, I hope you remember our department relation. If not, we can go back and refer the notes. Where we had a department, we create using the command called create table department. And under that, we list all our attributes. So you will see under the department, there are 4 attributes. So we will create 4 columns: department name, department number, manager social security number, manager start date. Okay. So now the second part is you specify the attribute together with their data type. So varchar is a data type in Oracle. Varchar means variable character, which means, okay, you can have a number of characters. So that this number will specify the maximum number. So you can go up to 10 characters. It's like this. Now, when you fill in forms, when you type, you will see you can type any number, but there will be a maximum number of characters you can enter. So this 10 specify the maximum. So simply the storage size is like if it is 10, it might be 10 bytes. If you type only 5 characters, then it might use 5 bytes. So that's why we are using variable character here, because the department name could vary. To save some space, we are using this particular data type called varchar. Actually, there's some in SQL we have normally talk about varchar only, but in Oracle it says varchar. That's what you need to use. Similar to that department number, we assume that it's an integer value. That is a whole number. So we put the data type as integer. Okay, can anyone of you can guess what char is then? Yes, anyone of you can tell me what chart I am. That means characters, right? And within bracket it says 9. So maximum is 9, right? It's not just say maximum. So you have to have 9. So there's no variability here. So manager social security number means manager social security numbers. So you are allocating 9 characters. Okay, that's what it means. Manager social security 9 characters. So every time when you type, it will allocate 9 characters. It's fixed. For example, if you want to store gender, can you tell me how should I give you the data type? Let me say gender.
Can you increase the volume voice? Please, bit faint.
Hello?
Yeah, you are not clear at times.
Okay.
Thank you.
Let me check. Okay, I'm going to check my microphone. Hello?
That's good.
Let me use a separate microphone. Let me. I have changed my microphone. Is it good now?
No, it's not clear now. Okay.
Hello?
Now you are clear.
Okay, let me know if it is not very clear. Right.
Thank
So
you.
we were discussing about how to create tables within a database. And the example we got is department. And here is the command that we are going to use. I hope you understood the idea. So each of the attribute, we will specify the attribute and its data type. And there are several data types which I will discuss later on. For the time being, department name, we say varchar to 10. Department number is integer. Manager social security number is a character, 9 characters we allocate, it's fixed. Manage start date, we specify as date. So that's the format. Then we talk about some constraints. For example, we say we can use the term called not null, which indicates that you have to provide a value for this column. So that means when you are entering data, you cannot have rows without any data for these two columns. So department name and department number, they are both set as not null. So that's the basically idea here, right? So that's about the theory. I hope you got an idea, right? And then there are things something like this. For example, I told you, when you're creating a database, you have to take one of the attributes as a primary key, right? So the primary key can be used to say in SQL what the primary key is. So you can see the department table. Now this time we have included the primary key statement here. So these are the 4 attributes we have: department name, department number, manager social security number, manager start date. So these are we describing all the attributes, or that means the columns. Okay, this one primary key specify what is the primary key attribute. Then we say department name is a unique. So the unique indicate that it's unique to each and every value. So I hope you remember in our conceptual model, both department number and department name be taken as a key attributes. Right. The last item is the connections. I hope you remember that we have seen when you want to connect to another table, we use a foreign key approach. So here we specify what the foreign key for this one. We say the 4 attributes we have, we say manager social security number is the foreign key, which refer to our employee table, right? So we specify that, okay, which attribute we are going to use to connect employee table. So that's what it means. So I hope now you get a basic understanding how you may create a table. Again, remember, next class, we will physically, practically, we are going to execute this one and see, right? So those who want to try out at home, once you get the note, you can try it out. Right, now we need to know a little bit more about attribute data types in SQL. Right. Now, any data can be put into as numeric data. That means you have numbers, or character string, you can have some texts. Bit strings, which means sometimes we call binaries, or you can have ones and zeros. Boolean, we say normally, say you can have true and false values. And the last one is you can have date and times. Right. If you take Oracle, for example, we have a separate, data types we specify for each of these data types. So in general, I'm not going to referring Oracle particularly here, but if you refer particularly for SQL, usually you have to have data types like this. For example, we have something called integer or small integer, right? Or we will have something called float. You can have something called decimal, right? Oracle one I will discuss separately when I discuss. So for the time being, I want to discuss in Oracle also support something called a number, right? And then you have something called float. And then we have something called binary float and binary double, right? So whenever you need to make changes, I will let you know how to use them. Second one, you can have character data types. So usually you can have char or character fixed length strings. So you have already witnessed, so that you can type either char or within bracket you can specify a number. So that n will define how many characters are allowed here. You have seen earlier that we have specified character 9 for manager social security number. That means we are allocating, right, 9 characters for that. So that's what it means. Right. Now, having said that, there are others as well. For example, you have Vacha, and I told you in Oracle, it's slightly different. You can have Vacha in Oracle as well, but most commonly or most preferred one is varchar 2. And you can, within bracket, you specify the maximum number. So this is called variable length characters, right? Then you can have very large one. Let's say you want to have documents, right? So in Oracle, if you want to use very large data, then we use something called CLOB, C-L-O-B. So character large object. So CLOB stand for that. So the CLOB is used. Right. Then you can have bit strings, binaries. In SQL, we have something called bit, or we have blob. Oracle also use blob, binary large objects. Oh, it says row, R-A-W, row. Usually in binary data types available in Oracle goes as row, long row, and blob, and so on. Then data types, date and times. So usually when you want to specify date and time, you can say date, right? Or you can have timestamp. That means you can include even the fractions of seconds with the timestamp, right? Those are the main ones. Right. So we can use various ways to define what the data type is. Right. Then we can hold in interval as well, which is not available in Oracle as well. You have seen that there's a comment on MySQL. It's not available in both cases. Right. Now with that one, we discuss about the data types. The next thing that I would like to discuss is the constraints. Constraint means you have limitations or you have special cases that you want to refer it to when you're defined. So for example, I told you, if you use not null, that means you have to provide some value. We normally say null is not permitted. When you say department name, we say it's not null, which indicates that you have to provide some value for that. Right? Similar to that, we can specify there's a SQL statement called default. Now, what do you mean by default? Default means you can specify particular value. For example, I can say, okay, department number, integer, not null, default 100. What it means, if you do not specify any particular value, it uses 100 at 100 as a default value. So that's what it means. Right. Primary key we have already discussed. So primary key can be used to specify what attributes are used to make the primary key. Unique also we have discussed, which specify that it's unique. Each and every value in that is unique. Then foreign key, meaning we discussed that when you want to make tables, we'll take some attributes to make that relation, which we call the foreign key. And finally, you can use the constraint to provide a name. Okay, now I think we have understood what are the things needed to create a table property. Right. Now, when we have a foreign key constraints, there are a few things we need to set up. Let me explain this with the example. Now, let me say something like this. I hope you remember the database we had. So in the database, we had employees, right? So I will type like this. Okay, I had employees. We had employees. We will say employee. Okay, we had first name. We had last name. It's something like this. And we had address and so on, right? I will not put everything. So this is how we design. Then we have department. We have department number, department name. We can have something like this, right? Now let's say we know employees are working in departments. Right now I didn't put the foreign key constraints. Now to make the connection of these two tables, we have to put, right, primary key in the other table. So let me put this as a social security number as the primary key. So let's say we have two primary keys, social security number and the department. Now tell me to track, now employees works for department, to track the department those employees are working. In which table we put the primary key of the other table? Did you get my point? So let me give you some more information, like let's say if you take some values like social security number, first name, last name, address. So let me say social security number, let's say 111, someone, Nayak, let's say Kalab. So you can have some information like this. 222 Kamala Silva. Let's say Candy. So this is some data records. This is for the first table. Let me put another table that is department. We have department number and department name. Let's say 100. We can say research. $200 HR. Now my question is, these two tables are not related to each other. To make the relation, we want to put primary key in the other table. So what is the best way to do that? Are we going to put social security number in this side or the department number in the employee side? If you remember the relation in between, this is one to many, right? We take one employee can work for one department, but department can have many employees. It's one to many. The many side is the employee side, right? So we have to put in the employee side. So ideal situation is something like this. We have to say, okay, department number, we have to put it like this. So we can say, for example, this person is working 100, right? This person works in 200. So now you can see the two tables are connected to each other. You got my point, right? So that means Kamala Silva works for HR department. Someone works for research department. Okay. So let's add another person, 333. Upul Nanayakar. Again, let me put 100. So Upul is work for department number 100. You got my point? Yes? Okay. Now here is a situation. Now if you have this data in your tables. Let's say you remove research. What should happen to these data points? Can you think what should happen? Let's say we are going to remove research from the table. But remember, right? There's a dependency because this 100 is already in other tables. How the database should be handled. So we are going to remove research. What should happen here? We have 100 here, we have 100 here. Yes, I need your response. Let me explain again if you do not understand the situation. Let's say we have two tables, right? In one table, we have employees, the other table, we have department numbers. To connect the two tables, we put department number in the employee table. So we know Saman works for research department. Upul also works for the research department, but Kamala works for HR department. My question is, let's say I'm trying to delete department research. What should happen to the data in table 1? That is my question. Any ideas?
It has to be set now.
Okay. So that means when you remove research, instead of 100, we are going to put null, right? That is what we call set null. So what it means, if you remove a department, right? All the assignments in the department, we indicate that it's empty. So that means we have to allocate them into some other department, isn't it? That's the situation. Good, that is one way to do this. What are the other ways? Exactly. In your reset, if they are related, can't delete. Okay, if the data is related, if you want to say, okay, don't delete anything, then we will say restrict. The term restrict is used in database definition to say that if the data is related to in some other way, we will not allow to delete. So you said if related can't delete. If that is the case, we say it's a restrict. The restrict means that, okay, before you delete 100, you have to make changes to the employee table. So that is the restrict means. Set null means when you delete, automatically this 100 will be set to null, which means these two persons, Saman and Upul, will not have a department. Last one, we call cascade. Now the cascade means it propagates the update, which means if you delete this, right? So that might remove these two employees as well. So that's what the cascade means. So that means, remember, when you are creating table, you have to think all this, right? You can't just put the data. You have to think, okay, what should happen if I delete the research department? Okay, one way is we will not allow to delete if there are already people who work for this department. That is what we call the restrictees. Or else we will say if you delete research, those who actually work for research department, we are not going to assign to any of the department. So those who work for research department, after deleting the research, you have null values, which means they don't have any particular department. Third one, cascading, which means that it's propagate. If you remove the research department, all those who work for the department research also removed from the data. So remember, when you're defining your tables, you have to think all these cases, which I will explain later on. Right. Let me give you some examples. Right. Now, in this one, can you see whether you can understand what is there? So we have a table called department. We have department name. Ideally, this should be varchar 2. I will make the change in the note. And the department number is integer. Manager social security number is character. Manager start date is date. Primary key is department number. We say department name is unique. Okay, this is a foreign key constraints. So we will say manager social security number here is a foreign key constraint, which reference employee, and it says on delete cascade, which means it should propagate. So which means when you delete ideally the department, right, employees also should be removed, right? So when we learn, we can put some data and see what will happen. Okay, similar to that, let me give you another example. Can somebody explain me what will happen here? It's again employee department. We have variable character. We have department value. Default we set to 1. We have supervisor social security number. We have 9 characters. Primary key is employee social security number. And in the foreign key, there are 2 foreign keys in the employee. We have department number. It refers the department. On delete, we set the default value because we set up the default value for the department number. But remember, in Oracle, there are slight changes of the default value. On update, it's cascade. If you make a changes, it should propagate. Similar to that, you have supervisor social security number, which refer to the employee in social security number. If you delete, you have to set null. So that means if you delete a particular employee, the supervisor social security number should be set to null, right? Otherwise, it should, propagate. Right. Okay. So with that, we conclude our discussion of creating tables. Similar to that, if you want to remove table, in SQL, there's a command called drop table. With the drop table, you type the table name. For example, if you want to remove the dependent table, we say drop table dependent, which will remove the dependent table from the database. Right. Similar to that, let's say you want to change anything in the table. Right. Now, when you say anything in the table, let's say we have an employee table. We want to add a new attribute called job. So in this example, what we do, we create an employee. Sorry, we under the table employee, we add a new attribute or new column called job column with variable character 12. Right? So we can use to add attributes. Right. Now that we have discussed about creating database and creating table structures, let's look at how we can get the data out from the tables, right? Now, the basic statement that we are going to retrieve data is called select statement, right? So when you select, we can get data from 2 or more, right, from the tables. And then depending on that, we will get the outcome, right? So for example, when you use SQL, if you have multiple data points with the same value, it will output exactly as it is. Now, for example, let's say you are trying to get a person's name, and let's say you have 2 summon in your database, it will show you both the names, right? In case if you need only the distinct value, in SQL, we have to use, there's a keyword called distinct keyword, which we can use to uniquely identify each of the records, right? So in basic SQL, there are 3 statements. So we have select, from, and where block. In select, usually we say what we need, attribute list. For example, let's say we want to get the name only. So we can say select first name, comma, last name. From, we will have to say from where you need the data. For example, in case we have to get from employee, right? So one query could be something like, okay, select first name, comma, last name from employee table. Now, where is to make some conditions, right? Make some conditions. So we can limit the access. For example, let's say we can say, okay, I want to get person name, right? If the first name is Saman, so then we can write like, okay, select first name, comma, last name from employee where first name is Saman. So let me put it in writing. So one example, I can say, okay, select, right, first name, comma, last name from, let's say, employee table. If you just like this, it will print all the first name and last names, those who are in the employee database. But you can select, you can say, okay, where we'll say F name is Saman. So what this does simply, okay, we want to get the first name and last name from the employee table where F name is Saman. So you retrieve the data, only F name is Saman. So that's what it means. Okay, so I hope you got some basic understanding about how to write queries here. Right. Now, when you're writing queries, there are queries which is very direct. Direct means the example I gave to you. Okay, I need the first name and last name, whose first name is Saman. It's a very simple query, right? So simply basic ones we can talk about just using a single relation. That will be very basic. But if you want to try to combine data coming from various different tables, then this becomes very complex. So let's start with some queries. Right, here is a query. Retrieve birth date and address from the employee whose name is John B. Smith. From the simple example I explained to you earlier, can you give me a SQL statement for this? Let me give you the table structure. Right? The table structure is, you can see the table structure. You have employee, first name, middle initial, last name, social security number, birth date, address, sex, salary, supervisor, social security number, and department number. These are the attributes we have. So having said that, okay, how do you write the answer for this? Now, first thing that we discuss is you have three things. What are the three things? Right? We will say, okay, select. Yes. From. Where? Can you tell me what to select? What are the attributes that we have to select? By looking at this table structure, what do you have to select? Yes.
Birth date.
Okay, birth date. I will show you again. Retrieve the birth date and address of the employee whose name is John B. Smith. So we have to get the birth date, good. And then
Address.
just the address, right? So we can say here, okay, we need to select what? We need to select birth date. Okay, sorry. Birth date, comma, address. Okay. Now from which table we want to refer this? Birthday at birth date and address. Which table or which relation? It's from the employee, right? So we have to say, okay, from employee. Now, if you just use first two lines, it will list out birth date and addresses from all the employees. Okay, Nirmal gave me the complete answer. Yes. Where? Okay, now person name should be John B. Smith. So you can see there are three parts. First name, middle initial, the last name, right? So what we could do is we can put like this. So we say, okay, select birth date and address from employee, where first name should be John and middle initial should be B and last name should be Smith, which will give you the correct answer. Okay, can you tell me those who do not understand this, because this is the very basic one, which I want you to understand. So anything that you want to get, you should be able to use this select from where SQL statement to retrieve whatever the data from the database. Okay. So you can see select clause, we can say what attributes to retain, and the where clause, we will decide on what to select. what is the selection criteria, right, to select tuples for the from the data table employee. So that's what it means, right? Can you give me the answer for this? Retrieve the name and addresses of all employees who work for who works for research department. Okay, so I will give you the table structure. This is what we have, and this is what we need to answer, right? Retrieve the name and addresses of all employees who works for research department. What do you think about this? This is not a direct answerable question, right? So the name and addresses coming from here, right? So you can see here, name and addresses comes from here. We have name and address. So here we have name and we have address of all employees who works for the research department. So we need this table. What is the other table we need?
Department.
Exactly, we need both these departments, right? I think the first two lines is easy. Can you help me to put down the first two lines? We can say, okay, select. Yes. Name and addresses. So we can say F name, then middle initial, last name, address. Right? This is easy, right? This is what we need. When we say name, there are three parts. So we want to select all the three parts. And then when you say from what tables we are getting this information? So to get, we need both employee and department. What is the condition? Can somebody help me to figure this out? Okay, we want to combine both the employee and the department. So we will say first name, middle initial, last name, address, and we say we want to get both employee and the department. Okay, what is the condition? Okay, first thing is the department, right? So if you look at here, the department name should be what? Department name should be what? Right. Is that enough? Research. Okay. Telina said it should be research. Good. So we can say the department should be research. Right. Okay. Is that all? Okay. Remember, I think I have not discussed this idea. So let me explain joins here. So remember, now we are trying to combine more than one table. When you have a situation line like this, you have to specify how these two tables are connected to each other. So therefore, we can say, okay, and we can say which one connects to which. For example, we have employee, that is, we have department number, which should connect to the department number in the department. So the ideally we will specify department number should be equal to, right, department number. Here is the final SQL statement to do this. When you want to retrieve the name and addresses, we use first name, middle initial, last name and address. And then we can say from these two, where we will say, okay, department name is research and the department number is department. Any questions? Are you comfortable up to this? Okay, we need to do a couple of exercises. So therefore, now we have discussed, when you want to get some information from a single table, it's easy. But when you have more than one table, you list all the attributes, you list the tables, and then you specify the conditions. One condition is we have to specify how these two connects to each other. So we know that the department number should be equal to department number. Right. Can you think about the answer for this one? Again, I know that you have not given any details as such, but some information given for you to think about. Right? Okay, let's discuss the answer. Now, to do that, you need to understand what we have, right? So let me put what we have. Okay, let me go back. Okay, so this talks about a project. Yes. So we need the project database, or sorry, project table. Then you talk about department number. So you need the department, right? And then you need the last name, address, birth date, which is employee. So you have to combine three tables together, right? Got my point, right? So look at our table structure. Yes, can you help me to come up with the answer for this? What are the attributes we want to have? Yes. Helena? Let me stop for the time being. So in this particular example, for every project located in Stafford, we want to list project number, the controlling department number, and the department manager's last name, address, and the birth date. So what we did, we have first figure out what tables needs to be combined, and then we list all the attributes. So in this particular case, we say select P number, which represents the project number, then D number, the controlling department of the project, L name, that means manager's last name, address, and date of birth. From we list all the relations, we are going to combine tables, project, department, and employee. Where condition, we first combine project with the department. Department number should be equal to department number in the department, and manager social security number should be equal to social security number. And finally, project location should be Stafford. Right. Nirmal also use joint statement, which I have not discussed yet, just. And then you are using renaming operator as well. It looks fine for me, Nirmal. Simply you are trying to join separately. Okay. But the best thing would be, Nirma, like once we learn to create them physically, you check this. For the time being, your query looks good, but keep a record of this. We could try when we start implementing this. Okay, with that, I think we have about only 4 minutes. Any questions? Let me summarize what we have discussed today. We discussed finally mapping many-to-many relations and also the multi-valued attributes. And then we started looking at the SQL, things that we have discussed. SQL, common language we use to manipulate the databases. But then depending on the implementation, there are slight differences, which so some places I have highlighted what are the differences in the Oracle. And finally, we discuss about simple querying in using SQL. We discuss how to work with the one single relation, two relations, and in this particular example, we discuss handling with three relations. With that said, I conclude for today's session. Let's meet next Monday, but I will have a quiz based on the SQL so that you can get ready for the next session. At the same time, please have a look at your credentials for Google Express database. And I will also provide you 2 more links for Oracle SQL Developer and Oracle Data Modeler, which I want you to just have a look at it. But mainly, I'm going to focus on SQL Plus as a command line, which I'm going to discuss in the next session. And after that, I'm going to use the graphical user interface. So with that said, I will finish for today. Thank you, everyone.